Hi everyone, I'm Fraser Cain, publisher of Universe Today. Been a space and astronomy journalist for over 20 years. This is the Question Show. Your questions, my answers. We record this show every Monday at 5 p.m. Pacific time live. So you can come and ask your questions in the chat. I have no idea what's going to happen, and I will answer them and follow-up questions. It's a lot of fun. But also, I take questions from you wherever you want to put them, in anywhere in the YouTube chat, for patron chat. Send me an email. I will answer all your questions. All right, let's get into the questions. Ardent Defender. If the universe as we know it is expanding faster and faster every minute by huge scales, at what point does it reach the speed of light in expansion, and what do you think will happen? This is kind of a trick question because the universe is already expanding faster than the speed of light, depending on your perspective. And the universe is also not expanding faster than the speed of light, also depending on your perspective. So it all depends on where you are and the thing that you're looking at. So where we are here today, if we look over at Andromeda, Andromeda is moving towards us because it's gravitationally bound to us. And if we look farther away, we see galaxies that are moving away from us at some percentage of the speed of light. And if we look even farther away, they're moving even faster and farther and faster. And eventually you reach a point where the galaxies are so far away that they are moving from our perspective faster than the speed of light. And you're wondering, like, how can we even see them? And that's because the light had already left before the galaxy was moving away from us faster than the speed of light. And so for the galaxies, as they shift over that line, this cosmological horizon, they will just redshift and fade away. So the thing that's really important to understand is that the galaxies themselves are not actually moving through space faster than the speed of light. It's space itself that is carrying them away. And from our perspective, that's the key, is that the more space that's in between us and them, the farther and faster they seem to be going. And I think it's just really important to sort of contemplate that it all just depends on where you are in the universe. There will always be parts of the universe that are closer to us and they're not moving faster than the speed of light. And there's stuff that's farther from us and it is moving faster than the speed of light. And over time, more of the universe will have moved away from us, and eventually almost the entire universe will be moving so fast, and it will be essentially going faster than the speed of light from our perspective and fall over the cosmic horizon. And so if you could go forward 100 billion years, if you looked in all directions, you wouldn't be able to see really any galaxies because they were all moving so fast that they were fading away and just disappearing into the darkness of space. So what will happen? It already happened. And nothing's going to change. Zapfan, thoughts on SLS not launching? I mentioned in a recent Space Bites episode that I wouldn't be surprised if SLS was delayed, and I wasn't surprised. And then I wasn't surprised that it was delayed again. And I'm not going to be surprised if it gets delayed into October, and I won't be surprised if it gets delayed into 2023. This is a complex machine. It's never been flown. The stakes could not be higher when you think about the billions of dollars that went into the development of it, the billions of dollars to build each one of these individual rockets, the honor of the engineers, the credibility of everybody involved on the project, the politicians who signed it. Everyone's going to be embarrassed if this thing explodes on the launch pad or fails to reach orbit. There is a lot riding on this, and it is relatively straightforward to catch a mistake and decide that you're going to hold on the launch and wait for the next good opportunity. Take a little more time, double check everything, make sure that the issues that crop up each time you get closer and closer to launch go away. And I think a lot of people are really dramatizing the delays of the SLS. But if you go back into the Apollo program, it was delay city early on, and even later on in the program. if there was issues, they would delay them. And the shuttle, many of the shuttles were delayed. The launches were scrubbed. I was telling a story in the recent episode that I went down to go see the space shuttle launch for the second to last launch, and it was delayed for a month. And so I went down and I went to Miami and I visited some friends, and then I went home, and I didn't get a chance to see the space shuttle launch. So rockets scrub. And on an important rocket like this, it is not a surprise that it scrubs. And I would much rather this rocket launch safely and complete its mission than fail and cause just so much drama. So yeah, I trust them to take their time, double check everything, and make sure it flies. Rocket Gibsons. What's new with James Webb? Ironically, I went on hiatus, and then James Webb produced all of its first images. And fortunately, we were doing the other episodes, the Space Bite stuff, so I was able to provide a lot of updates. And we got that really great release of images in July. We saw the various nebulae, the spectra from a planet, and it was all really cool. And then the Webb team has gone mostly silent from a public relations perspective. We've seen a couple of stories come out. We saw the story that just came out last week about Webb being able to image carbon dioxide in the atmosphere of a planet. We also got a chance to see a direct image of an exoplanet, which was really cool, from Webb. But we haven't been getting a lot of stories and pictures. And I'm sure people are surprised that there hasn't been a lot coming out. Now, there's been a few citizen scientists, people like Judy Schmidt, who is just an amazing image processor. And she is watching where all of the photos are being dumped for James Webb into publicly available databases, and then digging into them and doing image processing on them. And they look fantastic. And then we're learning the science behind those images. And it kind of wouldn't be possible, wouldn't be happening if it wasn't up to Judy and a few other people who are digging through these images. And the reason is because the researchers, when they use Webb, they get 1 year that the data is only for them, and that they get to scan the data, they get to write up their research reports, and then they get to try and get it published in a journal. And then when they're done, then the rest of the scientific community gets public access to it. And the public gets public access to it. So Webb is being used nonstop. It is recording image after image after image, and most of the data is being handed over directly to the scientists who had time on Webb, again, to give them time to do their science. And then at the 1 year mark, all of that data is made publicly available. And then that archive of data will build up year after year after year. So it's not surprising that there hasn't been a lot of news, because the way the process goes, you've got to get your time on the telescope, gather your data, you've got to analyze it, you've got to write up a result, you've got to find a journal that's going to be willing to publish you. Like, this takes months. And then we're going to start to see that rolling trickle of information and news coming out from James Webb. So there's probably a million new things, and we're just not aware of them yet until we catch up, that lag from when the images, the observations are done to when everything comes out in the scientific journals and then the news releases and so on. So be patient. It's coming soon, and we'll get just a deluge more information. Nick Poshek. Do you think NASA will stick with the Gateway as part of Artemis? The Lunar Gateway is this space station that NASA is planning to build and construct out by the orbit of the moon. It won't orbit the moon, but it'll be in a halo orbit that'll bring it very close to the moon on a regular basis. Will they stick to it? I think so. Back in the Apollo era, the plan for the missions to the moon was you built this gigantic rocket. It flew to the moon. It came apart piece after piece until you were able to land the lunar lander on the surface of the moon. And then the astronauts could do their thing. Then they could get back in and dock with the command module and fly back to Earth. And just the little capsule was the part that survived in re-entry into the atmosphere, and the astronauts got out. And you had to throw away every single piece of the entire stack. It was very expensive and just a single use. But the Lunar Gateway changes the perspective. It says, okay, we're going to make flights to and from the region around the moon a common occurrence. And then we're going to have a spacecraft that can fly from the Lunar Gateway down to the surface of the moon, back up to the Gateway. And that spacecraft, it's probably going to be a Starship, is reusable. And so then you can imagine, well, maybe you could get to and from the Lunar Gateway in a reusable manner. And now suddenly you've got this ferry system. Astronauts are flying up to the Lunar Gateway and back down. They're flying from the Lunar Gateway down to the moon and back up. And then eventually you're going to have a base on the moon. You're going to have the ability to fill propellant for the spacecraft. And so it just turns into this reusable, sustainable, long-term exploration of the moon. And having a space station that is flying near to the moon is a really great part of that, to break up the trip into the various times that you want to get into and out of the moon's gravity. It's kind of like a permanently orbiting command module when you think about it. So if the plan is to just put people's feet on the moon again and then never do it again, then no, the Lunar Gateway doesn't make any sense. But if the plan is to stay, then the Lunar Gateway makes a really smart stepping stone. And you can imagine it being a prototype for future exploration of the whole solar system. Imagine there was a Martian gateway, something that was orbiting, or, maybe it's on Phobos, but imagine a space station that's orbiting around at Mars, and maybe something orbiting around Venus. And you fly to these stations, and then you can refuel and go down to and come back up. And if you need, there can be a rescue effort. Like, it just makes sense. It's infrastructure. And the more infrastructure that we get in space makes a ton of sense. And so I can imagine NASA moving towards this idea of infrastructure. Gonzalo Lozada. Do you think that we could make an engine that just catches particles from space and accelerates them to generate propulsion? Infinite fuel. So every idea has been thought of, and this idea is known as a Bussard ramjet. And the idea is that you've got this fusion drive that runs on hydrogen, and it's a very efficient, very effective kind of rocket. You can produce a ton of thrust. The key is that you're going to need a lot of fuel. If you want to go interstellar, you're going to need a lot of fuel. Well, there are particles of hydrogen just floating out in space in between the stars. And so if you could scoop up all of those particles of hydrogen, bring them down into your fusion reactor, you would have an unlimited source of fuel. Wherever you go, there's just going to be more hydrogen. The faster you go, the more hydrogen that you're able to scoop up and feed into your fusion reactor. And it just seems like the perfect idea. And this idea was popularized back in the 1960s. And it was called the Bussard ramjet. Now, the problem is, well, one, we don't know how to do fusion, so there's a problem. But the other problem is that although there is indeed hydrogen out there in space, there's not a lot. Like, there is a few atoms per cubic meter, a handful of atoms. The harshest vacuum that we could possibly make is way denser than the vacuum of space. It's very empty out there. And so someone fairly recently did new calculations based on the idea about what kind of a magnetic field it would take. And they calculated that you would have to build a magnetic field that stretched between the Earth and the sun. That was like 140 million kilometers to be able to gather enough hydrogen to be able to run a Bussard ramjet. And we don't know how to generate a magnetic field like that, or even a fraction of that. So there are a lot of issues in trying to gather your fuel. And that's really the only idea that is about gathering your fuel as you go. I mean, there's ideas about shooting your spacecraft with a high-powered laser and it's able to accelerate using the solar sail. And there's ideas about more compact forms of energy like antimatter. But to be able to gather up your fuel as you go, sort of like sailing, right? Like when you sail, you're just gathering new wind all the time. And it would be really cool if you could extract this hydrogen out of space itself, because it is there. But right now it appears just too difficult for us to work with. So probably not feasible. Bravo01. Why is the private sector, SpaceX, more successful and faster than the government agency, NASA? private companies like SpaceX don't have the level of regulation and requirements that a government agency has. Just to give you an example, the Space Launch System isn't just a rocket that NASA is building. It is a rocket that Congress, the United States Congress, has written a law that has demanded that NASA build this rocket and has defined who the partners are to help build this rocket and where the parts of this rocket have to be built. Can you imagine? Like if you tried to take on some project and someone handed you a law and said, if you don't work on this project in this very specific way, you will be in violation of the law. That's the situation that NASA is in. They don't have the freedom to decide which rockets they're going to build, where they're going to send them, all of that. These are choices that are made by the government. And for the projects that it does have these laws that are assigned with them, it has to go through all of the checks and balances and has to, it's a whole bigger thing. But for the projects that NASA just develops internally, they go great. They go really fast. When you look at spacecraft like TESS or Perseverance, internal projects, NASA is able to invent them, develop them, and complete them on time, on budget. Goes really great. But once you expand out what's happening, it becomes a more complicated, more expensive, more time-consuming thing. And who knows what compromises were made to get to the point that SLS was built. I mean, we're only aware of some of them, but I'm sure there was a lot of stuff that happened that people had to give and take to be able to make this project come together. But SpaceX and the private industry, they have to make profit. And so we've seen tons of rocket companies just go out of business because they couldn't raise enough money. SpaceX is the one that survived, but there are dozens, hundreds of new space rocket companies that thought they had a clever idea for being able to go to space, and they are gone now. So that's the risk. That's the downside. And SpaceX has been able to luckily maneuver through this situation where they've been able to raise the money, be able to bring on the clients, be able to launch their rockets and be able to reuse them. And now we're at the point where they're going to be launching Starship. I mean, Musk has said that they were one bad launch away from bankruptcy and being just another story on the road to space exploration. And it didn't have to go that way. So on the one hand, you got the safety and the security and the inevitability of the work that's being done with the government. On the other hand, you've got the speed and the agility, but the riskiness of private industry, and both have their role. NASA and SpaceX are really a partnership in many ways. Many of SpaceX's launches were purchased by NASA. NASA gave the money early on to help them do development and to be able to be pretty much their biggest and their first customer. And now they're at a point where they're off and running and things are going great. And NASA is getting still lots of missions through them. So I think they're two different ways of approaching a problem, that when the problem is unsolved and just so expensive and so difficult and requires expertise and a certain long-term commitment, that's the kind of thing that governments are good for. And when there's money to be made, that's when private industry can step in. And you never really know when that transition is going to happen. When have you gone from it being a challenge, risky, unsolved problem to a commodity that is reusable and the private industry, commercial industry can take over? It's different for every field. So I think that SpaceX has the potential to be, in the end, more successful and faster than government agency, but it also could go out of business overnight. And you have to be ready for that as well. More questions in a second, but first I'd like to thank our patrons: Zero Chill, The Braviloquent Caveman, Jeff McDonald, Gayton Venzina, Wayne Spence, Stephen R. Thamdrup, SGOJ, Brian, and the rest of our 1,024 patrons for their generous support. Want our videos with no ads? Join our community at patreon.com/Universe Today, and I will also remove all the ads from Universe Today for life. Neurostream. Will SpaceX have humans on Mars before Artemis has people on the moon? No. I'm going to say no, but I might say maybe. So right now, the Artemis mission is expected to put people on the moon by 2024. But come on. Like, we know that's not going to happen. So maybe 2025, 2026? SpaceX has said they're going to have humans on Mars by 2024. But come on. Right? We haven't even seen the first launch of the Starship with the Super Heavy. Maybe it'll happen in the next couple of months. Maybe it won't happen in 2022. It'll happen in 2023. You need 9 months to fly to Mars. So you'd have to have a couple of successes and then have a module in Starship that is capable of keeping human beings alive for 9 months, landing on the surface of Mars, bringing them home safely, etc., etc. That seems like a tall order. So I can imagine a few more delays with Artemis getting humans to the surface of the moon, but like by 2028, for sure, they'll be on the moon. I can imagine it taking a little longer to go to Mars. So right now, I'm going to guess, it's just purely a guess, that NASA will have humans on the moon before SpaceX has humans on Mars. But SpaceX might have humans on the moon before NASA has humans on the moon. That's a real possibility. So, it's kind of anyone's game at this point. It's exciting, isn't it? Bobby Reynolds. Can a black hole get crushed by its own gravity or eat itself? Like, a black hole is already crushed by its own gravity. Like, it wouldn't be a black hole if it wasn't matter that's crushed by its own gravity. If you took, like, maybe 10 times the mass of a black hole and you just let it hang out there, it would collapse into a giant star. The star would die as a supernova, and then it would form a black hole at the middle because the gravity is too strong for it to be able to resist. So it's already happened. But, you know, what's kind of interesting is that black holes can eat other black holes. Like, what if a black hole got too close to another black hole and fell within its event horizon, and then the two black holes just merge? But yeah, like, a black hole is already the result of being crushed by gravity. Like, as far as we can't imagine a more crushed by gravity situation than a black hole. Gauri Shankar. As time is relative for observers, how can we define the age of the universe as 14 billion years? That's a tricky question. So I'll try and give an answer. So when we think about the age of the universe, the way we measure that is by measuring the speed of the cosmic microwave background radiation. We know that when the light from the cosmic microwave background radiation was released, it should have had a temperature that was like roughly the temperature of the surface of a red giant star. But when we look at it today, we see it just a couple of Kelvin above absolute zero. And the temperature change is due to the redshifting, the fact that that light has been moving away from us and farther and faster away. So you can just run the clock backwards. You can measure the temperature today. You know what the temperature should have been when it was released, and that tells you the distance, and that tells you how long that light has been traveling, which ends up being about 13.8 billion years. And so, you know, we used to think that the universe was between 13 and 14 billion years, and then when astronomers measured the temperature with the WMAP probe, the microwave anisotropy probe, they were able to see that the temperature with such precision that they were able to revise that number to 13.7-ish billion years. And then when the Planck satellite came out, it was able to measure the temperature of the CMB with so much accuracy that now we know that it's just shy of 13.8 billion years. So that is how they determine the age and the time. But you're right that as things are moving away from us, then our time is relative. And astronomers have accounted for that. So there's sort of an interesting quote that I learned that is, if you take into account relativistic effects for the movement of us compared to other objects across the observable universe, we can be off by about 30,000 years. So just the time dilation that adds up over time. And the reality is, it's just that these far off places just aren't moving fast enough away from us yet, and haven't been moving fast enough away over time. And so the amount of time dilation hasn't really piled up. But astronomers take that time dilation into account as they measure and consider how fast and how far the light has been redshifted, and they're able to make that calculation. Leaf binder. Do you think that politics will end up being the straw that breaks our space industry? I don't think so. I did a recent interview and we were talking about space, and the reality is that everybody loves space. That you meet a person and you may not know their political affiliation, but you could be pretty sure that they love space, that they love pictures from the Hubble Space Telescope, that they're fascinated by the discoveries being made on Mars, that they wonder about the cosmology of the universe, and that they like to watch science fiction. So, like everybody does. Nobody hates space. And you would be quite surprised at the political affiliation of the people within the government who are big supporters of space. In many cases, they can come from different parties that totally disagree on all kinds of things, but yet they're big proponents of space exploration. Now, sometimes they have various reasons. Like in some cases, they see it as a race with other nations. In other cases, it's a way to increase science and technology development within the country. But I find that space exploration in general and astronomy funding and science doesn't really fall down along party lines. And so it's like one of these things that's almost immune to politics. You know, you could hear a person describe their position on space exploration and you wouldn't know their political affiliation. I think that space industry is one of those few fields that is almost immune to politics. YouTube Joseph WM. Mr. Cain, I think NASA should stop sending robotic missions to the moon and Mars, and in cases Venus, they explore them enough for that money to be spent better exploring elsewhere. Please respond. There are really useful reasons to explore the moon, Mars, Venus, as well as all the other places in the solar system. So let me give you a few examples, right? The moon is really close by to us, and it has on its surface this historical record through the regolith, the crushed up rock on the surface of the moon, of pretty much every single event that happened in the solar system for the entire history of the moon. In many cases, all of the events that have happened in the history of the universe for the while, that the moon has been around. Every single gamma ray burst, every single coronal mass ejection has deposited material onto the surface of the moon, and it's there in layers, kind of like bringing up a core sample from the ice in Antarctica. The moon tells us about the formation of the Earth. And there's a lot of value in being able to do that. And of course, that's just scientific questions, not to mention the fact that moon has all of these really interesting resources that we could use to harvest to be able to try and get a self-sustaining colony on the moon. Mars is like one of the most likely places in the solar system that there could be life. There could be water underneath the surface of Mars. There could have been life in the past. There could be life there now. And if we find life, are we related to that life? And if not, how did it form? And if we are related, when did that happen and how? Venus is like the Earth and with the same mass and gravity, and yet it went completely different. We have plate tectonics on Earth, but Venus doesn't have plate tectonics. Why not? What happened that shut that planet down? It could, Venus could be in the habitable zone of the sun. So could Mars. But Venus has the same mass as Earth. And so you could imagine a version of Venus that had water on it and was habitable, and maybe it had life in the past. So those are all really interesting places to explore. The other thing is that they're close. The moon, Mars, and Venus are all within a couple of years to get to. The moon within a couple of days. So you can do really quick turnaround in your science. But obviously there's a ton of really interesting places to go in the solar system. There's asteroids, comets, there's the giant planets, there's the ice giants, there are all of the objects in the Kuiper Belt, all of the dwarf planets. Each one has a story to tell. So I wish we had more spacecraft and more ways to be able to explore the solar system, but everything is interesting. And some things are easier to get to and more convenient to understand things about them. And that's why you just start with the low-hanging fruit and then you move up from there. So let's explore all the things. Arjone, how is AI being used for space science, if at all? Well, I mean, AI is being used for space science in a lot of ways. Like now, a lot of astronomers use machine learning when they're looking at their archival data, when they're looking at vast amounts of craters or galaxies or things like that. And for the longest time, it was pretty tricky to get machine learning to be able to make sense of that. But in recent years, it's just gotten better and better and faster and faster. And now you can train artificial intelligence on the shapes of different kinds of galaxies and then have it find them. And we've done stories on Universe Today about asteroids being found, about stars being categorized, galaxies being found, and a lot is being done with machine learning. It's finding planets and so on. So I think so on that side, it's doing an incredible job. And then on the other side, you've actually got the machine learning or the artificial intelligence that is being part of a spacecraft. And so you've got Ingenuity, you've got Perseverance. Perseverance had to essentially pick its landing spot as it was landing on Mars. They knew roughly where they needed to go, but because the communications time is so long, it had to look at the surface of Mars as it was rushing towards it and find a landing site and put itself down. And even when it's navigating its way across the surface, it has to pick and choose where it's going to go, the paths it's going to take. And we're just going to see more and more of that into the future. If you're going to try and send a spacecraft out, a rover to Europa, where the communications time is now measured in an hour, you want to make sure that you've got a spacecraft that is capable of taking care of itself, that isn't, it's not going to wait for every single command that you're going to send it. Now move 1 centimeter forward. And then you wait an hour, 2 hours for the return trip. You're going to want it to be able to make a lot of decisions. So I think we're going to see spacecraft and especially rovers and things like that with a lot more autonomy, being able to make those kinds of decisions. So it's with every field, AI is making an impact, and it's happening in space and astronomy, no question. Fugal. Is it possible to test the effects on long-term low G on humans by placing returned astronauts into a liquid with, say, 38% buoyancy in order to test how we cope with new Mars arrivals? That's a really interesting idea. Like, you're taking astronauts that have been in space for some period of time, say 6 months, and then you're bringing them back down to Earth, and instead of having them go straight into full Earth gravity, you're putting them into a simulated Mars gravity and then seeing how well they do. Now, I think it would be tricky to keep them constantly underwater, but maybe for an hour or two, you could have them run a bunch of experiments in this tank and then move on to the next stage. I think that's a really great idea. Now we actually covered a story like this on Universe Today just a couple of weeks ago, and I'm sure this is what triggered your brain, is that researchers did some simulations. They took the various astronauts, they measured their muscle strength, etc., and then calculated how difficult of a time they would have after a 6 to 9 month flight to Mars. Would they be too weak to just perform the initial urgent tasks when they got out onto the surface of Mars? And the answer was they'll be fine. That the low gravity will give them a nice smooth transition from weightlessness to gravity, and they'll be able to perform their immediate tasks. They'll probably have to take it a little easy, but they won't be debilitated. But if astronauts had to fly to Earth after being in space for a year in microgravity and then immediately do things like batten down the hatches and set up their shelters and fend off bears, they would have a hard time. They would be weaker, and they would have, you have fluid distribution problems. You can have dizziness. You can imagine it being a very tricky process for them to come back to Earth. But it seems that Mars is okay, which is fortunate. But I love that idea. All right, those are all the questions that we had this week. Thank you, everyone, for hanging out during the live show and asking them, as well as everybody who asked questions in the YouTube comments. We do the show every Monday at 5 p.m. Pacific time. So if you want to come, hang out, join the live show, you can. There should be another event posted here on the channel right now somewhere. Maybe it's over there. Maybe it's over here. I don't know. But come and join. All right. Thanks, everyone. And we'll see you next week. If you want a single comprehensive resource for space news, you want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. And did you know that all my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes. Thanks to all the moderators, and a special thanks, as always, to Chad Weber, Nancy Graziano, and Anton Poznikov.